Hi, it's Kiffin Bates here in video 3, covering a loose number of topics such as segregated witness, transaction malleability. I think at a later point I'll be talking a bit more about the Lightning Network. For now, I just wanted to dig a bit more into how Bitcoin transactions used to work and how they work now after segregated witness, because I think the key takeaway is by separating the signing and therefore validating of a transaction separate from the actual transaction itself has all sorts of interesting ramifications. And I guess the analogy that I can draw here is that a Bitcoin transaction relies on these inputs, which are like checks that you've received that mean that you now have access to funds, and these outputs, which are you making payments onward using those funds. And a check has an amount, who it's paid to, and a signature to validate it. And a check also has a serial number on it so that you can track which checks you wrote and whether or not they've been cashed. Now, with the old Bitcoin protocol, the serial number of the checks was determined including the signature. But actually, it's not essential to do that. There's no real reason. I mean, it seemed kind of a sensible thing to do in the early days, but I guess in the early days, people weren't thinking about building other layers on top of the Bitcoin system. And if instead you create the transaction ID purely from the transaction itself and you keep the signature separately, then you can enable all sorts of clever things, such as delayed signing of transactions. You withhold the signing, but you release the transaction to another party, and then when they do the work that you're paying them for, then you can sign it. So it kind of allows for later date payment. It can also allow multiple parties to authorize the signing of transactions in a way that multi-sign didn't do before. Again, you could have a number of parties, and at some point in the future any one of them can say, right, I think it's time to now sign this transaction and make it broadcastable and have it committed to the blockchain. So really that's what it boils down to. It is simply a matter of, instead of the transaction ID being calculated from the transaction itself and the signature, you're just calculating the transaction ID from the transaction itself. And that's what means that you can't go in and at a later date fiddle around and artificially change the transaction ID and cause all sorts of problems for all sorts of different projects and people. I hope that clarified some things, and tomorrow I think I'll talk a bit about the Lightning Network and how it interrelates with Segwit. Bye for now.